Good evening and welcome to the Kepler Astrological Research Team. I'm Courtney Roberts, and to my left is Dr. Glenn Mitchell. And Mitch, we are so happy to see you here tonight. Mitch is in Tallahassee, and they've had a rough week. You want to give us a little rundown on your adventure?
Well, we had the hurricane come through and we lost power for several days. We've got to throw away everything in the freezers, the refrigerator freezer and the freezer out back. But power came up early Sunday morning, about 2 o'clock in the morning, Sunday morning. Same with our internet connection, came up at the same time. So we've been back online since. And
that's the worst of it.
Yeah, the worst of it was we had trees fall. They didn't hit the house. They knocked out a section of my neighbor's fence, so we got to repair. But we've cleaned up the trees. So fortunately, the house was spared. No damage to the house at all.
But Tallahassee, even though it was, wasn't a direct hit, you guys got some pretty strong winds.
Whoa, there are trees down all over the place. There's still roads that are closed. My office was out of power until Friday morning, or until Sunday morning also. There's still trees that are still blocking roads around here. So still people without power in Tallahassee, in Leon County.
Well, yeah, I was, starting to wonder if I was going to have to do the whole class by myself, but we're really glad that you're here.
I was wondering too.
We're glad that you got everything hooked up. So we've got a pretty full agenda for tonight. We're going to start with our Nakshatra Project because we're looking for a little help with that, and that's part of the syllabus here with the Astrological Research Team is that we want to actually include our students in doing actual research projects and getting hands-on in doing the kind of work that researchers do, and that can be anything from the really sophisticated mathematics to actually some pretty simple stuff that we're going to be looking at tonight that not only helps the overall project, but I think the people that do it are going to have an opportunity to learn a lot about the nakshatras as well. So we'll get right into that. This is a Canaveral research project, and there's quite a team of people working on it. So I'm going to go to my screen share and go right into our Slack channel, because that's how we keep these things organized here, or at least how we try to keep them from getting away from us. And there's my screen share. I hope that you can see the Slack channel. Is that showing, Mitch?
Yes, yes.
Okay, very good. All right, so this is our Slack channel for the Nakshatra Project. And when we have a big project where there's a lot of different people working on it, we have to put it in Slack because otherwise it just gets all over the place. This project started back, I believe, in the spring, in like April and May. I started talking with Ehsan Kazemi in Tehran. And for those of you who don't know Ehsan, he's a lovely fellow, and he's a programmer. And he's in Iran, so he's got a unique kind of Persian heritage. He does Vedic astrology as well as Western, but specifically he's a programmer. And he's got a program called Bindu that's mostly Vedic astrology. And he has developed something called the Saptarishis program, which actually does research functions in Vedic astrology. And most interestingly, the Saptarishis will do research functions in the nakshatras. And the nakshatras are the ancient Indian lunar zodiac. It's perhaps older than any solar zodiac, and there's a tremendous amount of lore and legend that's developed around it. And I'm getting a lot of noise, so I'm going to have to like mute people here. Okay. So there's quite a lot of material, particularly online. Although the nakshatras are very popular in India, and when people who do any kind of Indian or Vedic astrology, it doesn't really come into Western that much. So working on this project, the nakshatras were new to me, and I have to say that getting into them through the project, it's been life-changing. It really has. It's really opened my eyes in a lot of ways, and I'm just really interested in doing more of this kind of research. And I'm still getting a lot of noise on the microphones here, so I'm gonna mute everybody for right now. Okay. So I was very excited when Asan developed that capability of actually breaking out planets in the nakshatras, because I don't know of any other research programs that will do that. You know, like on Jigsaw or Sirius, you can certainly get the Vedic Ayanamshas and Lahiri and whatnot, or sidereal. But getting the nakshatras planets, it was impossible before. Okay. So the first thing we had to do was get together with Asan and really work on learning how to break these things out in Septarishis. And he was incredibly generous with the program and provided everybody with the program. And the beauty of Slack is we've got all the communications and the sharing of the files and the data and whatnot, and the various meetings in here. And that's part of the beauty of using Slack, and I strongly recommend it, particularly for research, because you want some kind of a journal. You want it someplace where you can go back and you can see everything in one place, and all the communications, all the questions that are raised, all the different contributions that people have made, because all of that is important. You need a record of all of that, and Slack is really perfect for that. Otherwise, you know, it's in somebody's email and somebody's Facebook Messenger, and it's spread out all over the place. It all goes in one place in Slack. So that's, I've become really adamant about using that. So here we have it. It's all in here. And we did, you know, some different research on sidereal zodiacs and whatnot, trying to get started. And then Isan got us all in there, and he gave us a wonderful training on the Septarishis. And we were able to start breaking out the planets in the nakshatras. Our plan, very simply, was to test the nakshatras using the Gokulan professional data. The beauty of that plan is that the Gokulan professional data is a massive database organized by professions. It's already been gathered, it's already been checked for accuracy, and in fact there's quite a lot of experiments that have already been done on it by Kiosti and Collerstrom and people all over the world. So it's great that we can kind of fit into that category of research right there. But the Gokulan data is already in Bindu and the Septarishis and Sirius, because Bindu interfaces with Sirius. So, you know, it saved us all the work of gathering the data. Don't underestimate that. Now, there's some limitations here. If we're testing the nakshatras on the Gokulan professional data, you do have to bear in mind that the Gokulan data is a little bit dated. It's mostly people from the late 1800s and early 1900s. So when you're testing professional categories, you know, some of them have changed a little bit. There are some questions to be raised there. I mean, Gokulan certainly didn't have a professional category for like a social media manager or a launch specialist at SpaceX, et cetera, et cetera. So jobs have changed, but also some of the categories like, you know, doctor or scientist, you know, you could say they've changed a lot. So, okay, that's one drawback of using the Gokulan data amongst the many, you know, positives and pluses. At the same time, the nakshatras are such an old system, a very ancient system, and a lot of the meanings attributed to them, I think, are so ancient that, you know, it might be less of a problem using slightly dated data, but we'll see. We'll see how that all shakes out. But again, using the professional categories with the Gokul data just solves all your data collection problems right there. It cut the work down to size for us. So once we got those basic decisions made, Kiosti Tarvainen started chiming in, you know, about, are we going to have a hypothesis and what are we going to use for control groups? And he's still chiming in. Here's one of the messages from him. And Kiosti is, if you're not familiar with his work, Dr. Kiosti Tarvainen, he's in Helsinki. And, you know, he's always been my inspiration for doing the Kepler conference. I call him the godfather of the Kepler conference because he's the guy that started doing quantitative experiments on the Gokul data, maybe starting in 2006, 2007. And in the interim, he's published like over a dozen peer-reviewed papers showing positive results in astrological research. And, you know, that's first. I mean, don't take that for granted. You know, Kiosti's done a tremendous service to everybody that cares about astrology, and you know, we're really grateful to have him on the board and to have his input. And he's a big crusader for control groups. He's a big crusader for hypothesis testing. And in this case, you know, we don't want to just plow into the Gokul data and, you know, come out with numbers like this category's got, you know, so many moons in this nakshatra. That's data mining. There you're just fishing. So we wanted to get some kind of hypothesis up front. And the way we contrive to do this is very relevant to the kind of work that we're looking for some help with. Because Kiosti likes to test what astrologers have traditionally taught. He's got a famous paper that he did testing the Astrologer's Handbook by Courtney Roberts, which is wonderful. You know, he was able to find dozens of statements in there relative to professions and actually test them against the Gokul data and come out with positive results for a lot of them, which is pretty exciting for anybody like myself who started astrology with that cookbook, you know, back in the 70s before there even was an internet. So, you know, he happens to like that kind of experimental design. So for a hypothesis, what we decided to do was check with certain authors who had published work on the nakshatras and check the professional attributions that they've given to the nakshatras against what we actually discovered in the data. And traditionally, Indian astrologers talk about professions a lot with the nakshatras. There's quite a body of lore, so we were able to come up with 3 sources. Dinas Harness, and he's got a book that's online. We're looking from that. Heart Defoe's got another book, and Alan Anon has input the data from that. And then we also have a site called Astrovid in India, which is a large outfit that I met when I was in Calcutta earlier this year. And they have a lot of material on the nakshatras online from their work, and it has a lot of professional attribution. So we've got 3 different and varied sources for the professions related to the nakshatras that we're using for a hypothesis, and we're test our results against that. And in that sense, we're not using control groups per se, but we are definitely using the astronomical frequencies. Okay, and that is what I calculated on Jigsaw, and I calculated the frequencies for each category. Now, for those of you who aren't familiar with the Gokul data, it's on the Cura website, and It's pretty standardized. Again, a lot of experiments have been done on it. The data's been up there for some time. It's formatted so it can be theoretically imported directly into Jigsaw. It's harder. So there's X number of categories. Okay, there's actors. As a matter of fact, let me just go to our spreadsheet and familiarize you with the actual categories. Okay, there's artists, painters, there's journalists, and that's separate from writers. You know, we'll come back to that. There's actors, politicians, musicians, writers, military men, and sports champions. Again, most of these people are born in, you know, in the 1800s or maybe early 1900s up to about 1930, 1940, roughly. You know, it's a little bit dated. The journalists are separated from the writers. The writers are more like poets and novelists. They're creative and dreamy and imaginative, whereas the journalists are, you know, journal means every day, and these are, you know, that work for papers that, you know, publish on a schedule and on a deadline, or, you know, reporting on, you know, nonfiction kind of events. So that's why the two categories are separated. And in fact, in the work that's been done to date on these categories, there's some very significant differences between the journalists and the more creative, imaginary types of writers. So it's an important distinction. But these are the categories that we're working with, and these are the categories that, you know, Kiyosti's used in his work, etc. If you go to that Cura site, there's also quite a lot of data on genealogy, couples and their children, and again, all of that is freely available. You know, it's already been checked for accuracy and whatnot. So it's a good source. Again, if you have the right kind of experiment, it's wonderful, because it just saves you all the work of collecting the data yourself. And the categories are huge. You know, I think in this whole set we're talking about like 25,000 charts. So it's quite a bit of data. So going back to our project, instead of a control group per se, I calculated the astronomical frequencies for each professional category based upon the starting birth date of the category and the ending birth date, the earliest and the latest birth date within the professional category. And they were all, you know, slightly different. So we got some slightly different distributions, but I put those numbers in Jigsaw, and Jigsaw's great because it'll export it, you know, right out, and you can copy and paste it right into a spreadsheet. So they go right into the Google Sheets, and that goes right into Slack, and then you can share them very quickly. That's I think a huge advantage of Jigsaw over Sirius right there, is just, you know, the output and, you know, how quickly you can put it to use. I love Jigsaw for that. So I went through and got those astronomical frequencies, and those are very important. And here's some of the graphs from that. I hope these aren't, you know, too small, but here's the typical Mars distribution. This is in the category of actors. So you can see Mars has got a definite curve. Jupiter's got a definite curve for this group, and it spans from 1800 to 1944. Typical Saturn distribution. Here's your north node. Venus gives you the 5-pointed star. Here's your solar distribution, and I seem to have skipped something there. Let me back up. But I wanted to show you the lunar distribution, and this is important. As you can see, most of these distributions, they have a very distinct curve. But when you get to the lunar distribution, it's, I think it's in here somewhere, it's almost flat. Yeah, here it is. The lunar distribution is pretty flat. that's the one planet that gives you a reasonably even distribution, more or less, which is good to know if you're trying to do any kind of research on planets and signs. You can get exact birth times. Then it's good to work with the moon because you don't have to worry so much about the astronomical curves. It is generally pretty flat distribution. Also, when you're dealing with the nakshatras are lunar mansions. So the moon is the first thing that you look at with the nakshatras. Then Jagdish has done a tremendous amount of work on this project and I'm going to put his mic back on, and Mitch, and if I get any of this wrong, Jagdish, you can set me straight. But yeah, Jagdish has done some really extensive work in putting all of the nakshatra data for all of the planets, for all the different categories into spreadsheets in Excel, and breaking it out in so many different ways. And I have some of those spreadsheets here to show you. We'll start with the military men. And the part that I like best about it, he's got all kinds of data in here, but he literally broke it out, by planet. So you can see along the bottom, we have the 28 nakshatras from Ashwini to Ravati.
27.
Sorry, because you didn't use Abhijit in this, the weird one. Okay. And you can see the distribution of the sun very clearly through them. And then you can just go right along the bottom. Here's the moon, and there's some interesting peaks and valleys there. Mars, yeah, that shouldn't be happening. Mercury, Jupiter, Venus. So he did this for all the professional categories. So we've got the data broken out very nicely. And he also was able to factor in the astronomical frequencies to come up with some pretty good calculations of, whether we had anything particularly significant in this data. And I think the consensus, in a nutshell, was that there wasn't anything like, really dramatic that jumped out as being of major statistical significance. At the same time, practical significance, yes, because we've got all kinds of distributions that are really not at all what they should be. And that is interesting. There's a lot that we can learn from that. Now, we're on schedule to present on this project the first week of December, Sunday the 4th, at Dennis Harness's Vedic conference in Sedona. We're going to do a whole segment on research in Vedic astrology. So we're going to spend a lot of time on the Nakshatra Project there, sharing our results and some of the practical insights. I've started laying some of this out already. I'm going to share with you some of the PowerPoint I've been putting together, like for the actors, where I'm comparing the astronomical distribution with the actual distribution, etc. It's perhaps a little more interesting with the sun there. So we're starting to lay all of that material out, and it's good to have a deadline. And then of course we're going to present on it again at the Kepler conference late in January of 2019. So we'll probably have a little bit more done, and of course in Calcutta in 2020. Now, so the project's coming along. We've got, again, just a fascinating range of people that are involved in it, from Ehsan in Tehran to Kiyosti in Helsinki to Jagdish in Houston. Rahul pops in and out time to time from Chandigarh. I'm in Florida. Mitch is watching over us, making sure we don't do anything too crazy. And then there's Alan in Toronto. Alan Anon has come in the last month or so. And he's helped us a lot with the hypothesis. And that's what I want to talk about now is our hypothesis spreadsheet. As I said, we're working from 3 different sources. And the way we've organized this is, again, we've got a Google Doc spreadsheet that can be easily shared with anybody that has a Gmail account. And this is how we've been working out our hypothesis of what these experts say. Again, we're using Dennis Harness. His book is a source, and that's available online. So that's why we've got the link right there. Here's his page. And as you can see, he's got a section here on Ashwini, the first nakshatra, and right there he's got Ashwini career interests. And this is what we need the volunteers to help us with. If you would like to learn more about the nakshatras, this is a great way to do it, because essentially you're going to need to go to these sources and see, you know, what the career interests are. And then if that fits any of the categories that we have, then it is a judgment call sometimes, but you would put harness in that, you know, category. For instance, now we've got 3 sources here. Okay, so Alan's already done the book by Hart Defoe. Alan's already put Defoe's picks all the way through. As you can see, we've got the nakshatras across the top here. We've got the categories of the professions down the left. And then if they've said that this nakshatra tends to prefer this kind of profession, then you would put harness. Or in the case of Astrovid, you would put Astrovid. So we've got those across the top, all the way to Purva, Ashada, and Abhijit. And then on sheet 2, we have the rest of the nakshatras starting from Uttara, Ashada through Purva, Bhadrapada, and Revati. I'm sure I'm mangling those pronunciations. Jagdish, forgive me. I'm doing the best I can. But so it's pretty simple. And again, Alan has already done the ones from the Hart Defoe book, and I started the ones from Dennis Harness and Astrovade. And we've got the links right here to take whoever wants to work in this to the source. And I've also put another link here to this site. I just really love this Wikipedia list of the nakshatras because as a Western astrologer, it's easy to get confused. And if you're trying to figure out your own chart and like what nakshatra is my moon in and what nakshatra is my ascendant and whatnot, at least on this Wikipedia page in this list, they give you the nakshatra in the Indian zodiac and in the Western zodiac. So you can't go too wrong here, okay? So again, it's a chance to really help us out on an important project. I mean, the way we've set this up and with the kind of work that we're doing, I would hope that when we get this all presented and sorted and published, that, you know, it would be hard to speak or write or publish on the nakshatras in the future without making some reference to this work and to what we've actually found. And I can tell you already that some of it matches up with what the experts say and some of it doesn't. You know, and I think we're going to have some really interesting conversations at these various Vedic conferences in trying to get our heads around what the evidence is saying. So we're looking for some help with this, maybe 2 or 3 people that would be able to, if you have it, you just need a Google account and we can share the spreadsheet with you. It's got the links right there. There's 27 nakshatras, and then there's that little abhijit, which some people use, and I don't know if we're even going to include that. So let's say there's 27, and you go, I would suggest that like one person work from one source. You know, you don't want to get overwhelmed, but if you just took the Dennis Harness book and worked through that, I'd say you could get it done in a day. Alan did his very, very quickly. Same thing with the Astroved source. Oh, and I just want to show you that Astroved source as well. It's here. And they have a different page for each nakshatra. You would just go down here.
Arya Gamidar has said that she's willing to help.
Oh, that's awesome. Do you have like a Gmail address you could share with us? Let me back out of the screen share here real quick.
She says absolutely.
Yeah, because
there it is.
Okay, awesome. And I will collect that once Mitch starts talking, because I can share the spreadsheet with you right away. Do you have a preference as to, would you prefer to work from Dennis's book, or would you prefer to work from the Astroved site? If you have a preference there, what help is that?
She says whichever's most helpful.
Well, why don't you start with Dennis's? And then we'll get another volunteer to do the Astroved site. And I mean, you might want to go and just for your own instruction, you know, read the Astroved stuff too, but fill in the Genesis too.
She says it's a great way to learn.
Oh yeah, yeah, and I'm telling you, it's been life-changing. I've learned so much from this experiment already, and we haven't even gotten deep into the results yet. But just, you know, I'm watching the nakshatras all the time. I really am.
There's also an earlier message from Teresa. She said she was sorry she missed the beginning of the project. She references a good historical article on her website on how they changed since the 1990s, the lost zodiac of the stars, astrological use of the 27 lunar mansions.
Yes, I see that. Lunar mansions, lunar divisions. There's a good historical how they've changed since the 90s. Therese, can we put your mic on for a minute? I want to hear what you have to say about this. I'm going to unmute you.
All right, it's on.
Yeah, is this your article, or is it?
Yeah, it's mine. I've been working with well, I call them the lunar mansions now for a long time, and I'm kind of skeptical of a lot of the information that is supposed to belong to them. Most of it came out in the 1990s when the American Council of Vedic Astrology was formed, and then suddenly in that article, if you check it out, you see the traditional Indian meetings are very concise, very brief. They don't say much. So this is a whole big mushroom cloud that's happened since the 90s, and it's American-based.
Well, I think it's very interesting. Like when you listen to Indian teachers, I listen to some in Calcutta or even on the Astroved site, like their descriptions are just all over the place.
Yeah, it's
like a mushroom cloud.
That's what's happened.
I can literally tell whose famous chart they looked at before they wrote the description sometimes, you know? It's that egregious. At the same time, we're definitely seeing some results. We're definitely seeing some distributions that, you know, are at such a variance from the astronomical curve, and that are, you know, as I said, sometimes correlating with what the experts say. Okay. Yeah. And sometimes not. And sometimes not. So, you know, that's my whole modus operandi. Yeah. I want to know. I want to test. I want to see what the results are.
Yeah, and I think that's fine. You know, because you're checking really mathematical areas rather than, you know, all the different meanings of the lunar mansions. I call them lunar mansions because they don't align with the stars anymore like they used to. So it's yeah.
That's why I include that Wikipedia page, because it's easy to get lost. Yeah, you know, they give it to you in the sidereal, and then you're trying to translate it to your tropical chart, and it's Yeah, it's a fascinating subject, and the use of them is very old. But I totally agree with you. I think a lot of the interpretations are just so superfluous and over the top. And I sat in a lecture in Calcutta earlier this year in the front row with Dennis Harness sitting right next to me, and this very traditional old school Indian teacher was up there teaching on the nakshatras, and like Dennis and I were laughing our heads off the whole time because it was just so all over the place, just completely all over the place.
It's a wide open field right now.
Yeah.
Wide open area. Yeah.
Yeah. So like I said, I hope if we do this right, it, you know, they'll have to refer to this work in the future for some kind of reality check, you know, such as it is. So good. Did we get any other volunteers to actually work on the, anybody else want to take this on and learn some more about the nakshatras? Don't worry, we've got a lot of people watching the recordings. We'll get somebody else. But Arya, I'm gonna, as I said, once we'll start running the video, and I'll copy that address for that email address, and I'll get you into the file. And if you have any questions, let me know. But we really appreciate your help, and I hope you have a wonderful journey through the nakshatras too, because you know, there's definitely a lot there, but we've got a lot to sort through too. And yes, good. Okay, so that's the Nakshatra Project. Now, the next thing on our agenda is the chi-square and the wrappers. And for that, we actually have a video presentation that Bruce Schofield did for us that is so cogent and concise and actually entertaining in dealing with something that's dry, potentially dry, as the chi-square. I think he does a pretty good job of bringing it to life. So we're going to switch over and share that.
The topic chi-square test. It's a common statistical test in astrology, you know, because it basically answers the question of whether an observed, observations fit data in categories. And it works very well for things like signs, you know, where you have, 12 signs, and you're doing an experiment or a study where you've noticed that more mechanics and construction workers are born under one sign than another, and you collect a sample and then you test it out. And the fact that it relates well to astrology is interesting to me, because if you go online and you look up chi-square test, a lot of the examples they'll give you, and these are not given by astrologers, these are given by people that study statistics, will use this astrological example. Will use it. They'll say, we expect a certain number of people born in a certain sign, and invariably it turns out that it's not true for those examples. But astrologers have been using it for a long time, and they have found, some studies have found significance, but there are problems. The biggest, one is data accumulation, but that's the biggest problem with astrological studies in general. But let me say a few things about the chi-square test. First of all, chi is the X, it's a Greek letter. And then the superscript 2 is the chi-square. And it answers the question, does a sample of observed data fit a pattern or a distribution? Now, if you have, observed data, suppose you have, 12, well, let's just say this. Suppose you have a large number of people as your sample, and you want to know what signs they were born in. It's going to be spread fairly evenly, and so you would just take the mean of the number that you're using. Say, you have 12, your sample is 12 people, and you'd figure, one would be born in each sign. That would be the mean. And that would be the normal distribution. Now, there are some subtleties that maybe have been mentioned before in this group, and that's that people aren't born evenly throughout the year. There tends to be a peak in the late summer, early fall. In other words, more people are born in Virgo than Pisces. And, it's not a huge difference, but it's something that needs to be taken into account, particularly when you're dealing with a lot of, with a large sample. But continuing on, the null hypothesis in a chi-square test is usually that the sample fits the normal distribution. That if you have, 120, births, you figure there's going to be 12 in each sign. That would be the mean. But the way the chi-square test works is you calculate chi-square, which is the statistic. And then you determine whether this chi-square statistic stands relative to significant levels. Now I have here, for example, 5% or 10%. So 0.05 is 5/100ths, and that would be the 95% confidence level, right? 5/100ths is, plus 95 is the full percent there. So the confidence level, 95% confidence level, is considered significant in statistics, and that's kind of the the goal that you're looking for. But the 90% confidence level, which is 0.10, is also somewhat significant. So if your calculated chi-square statistic is greater than the significance level that you're looking for, then you reject the null hypothesis. In other words, if you come up with a statistic that is greater than the significant level of 0.5, then the null hypothesis is not the truth, and you might have something there. If the chi-square statistic is less than the significant level, you accept the null hypothesis. Now I'm going to explain this step by step as we go along, but this is the basic idea. Now, next slide. My example study here is a sun sign study of 48 top rappers. So, about a year or two ago, I went on the internet and I came across something that said, I know what I was doing. I was trying to see if rappers were born more in Gemini than any other sign. So I found this website, which I list here, famousbirthdays.com /profession/rapper. And they had 48 of them there, and they had their birthdays. So I took those, and my null hypothesis is that the birthdays of 48 top rappers are evenly distributed throughout the year, and therefore by zodiac sign. So if there are 48 and they're rappers and there are 12 signs, there should be 4 rappers born in each sign. So I graph these using Calculate, which is the freebie version of Excel. I don't know what you people are using, but Excel is kind of the standard, and then there are other companies. In this case, this was OpenOffice. Now it's Apache OpenOffice. But you can very easily make graphs, and this is a bar graph of the 48 rappers based on their birthdays. Now I have here the zodiac, and 1 would be Aries, 2 Taurus, 3 Gemini, and so on. And you can see that there actually were more Geminis born in this sample of 48 than any other sign, and none were born in Cancer, and so on. So it's interesting, but let's find out if it's significant, and that's where you call in the chi-square test. Now, the chi-square test is this formula here. Chi-square x to the squared is equal to the sum of the observed data minus the expected data squared divided by the expected data. I'm going to go all through this. But to begin with, our sample size is 48. Again, we have 48 wrappers. And we have the number of categories is 12 signs of the zodiac. That's why the chi-square test lends itself to astrology, because it works well with categories. So the number of categories, n, is going to be equal to 12. Now, an important concept in statistics is the degrees of freedom, often abbreviated as DF. And it's usually not n minus 1. The number of categories minus 1 is 11. And basically what that means is if the mean of 12 values is 4, then 11 of those values are free to vary. So in other words, you calculate a mean and you take that off from the number, and then whatever remains are called degrees of freedom. These other values are free to vary. So basically just think of DF, or degrees of freedom, as usually the number of categories minus 1. So we have the formula here, which I'm going to go through in the next slide. And you know, this sign sigma, this is you know, Greek for the sum, Greek letters for the sum of, commonly used in statistics. And the null hypothesis here is that the expected data will be very much like the mean. That when we run this test, we're going to basically get, you know, pretty much close to 4 wrappers per sign. And we're going to reject this null hypothesis if the calculated statistic value, x squared, is greater than the value of the significant level sought. Now that is usually indicated as x squared sub alpha comma n minus 1. Now what that means is the sub alpha is your significant level, and n minus 1 is your degrees of freedom. So, you know, again, it's spelled out that way. Now I'm gonna go ahead and move to my calculation here. Now I see my sign Courtney Roberts. I got to move that somewhere. There we go. Okay. So this is the sun sign, and they're numbered 1 to 12. So 12 is Pisces and 1 is Aries. And these are the observations that I took from that list of top wrappers. And there were 3 in Aries, 2 in Taurus, 9 in Gemini, 0 in Cancer, 5 in Leo, 2 in Virgo, 7 in Libra, 3 in Scorpio, 4 in Sagittarius, 4 in Capricorn, 6 in Aquarius, and 3 in Pisces. And the expected mean is 4. That's the mean, the average, you know, 48 wrappers, 12 signs, right? So when you do the calculation, and most people don't do this by hand. They do it with, you know, some kind of software online or whatever. It's very easily done. But I think it's worth just looking at what actually happens. So the first thing we need is observed minus expected. So if you take the observed 3 and you subtract the expected, you get minus 1. And for Taurus, the observed is 2, the expected is 4, so you get minus 2. For Gemini, the observed is 9, the expected is 4, so we get 5. So anyway, you do this for all the signs, all the way down there, observed minus expected, and obviously you're getting some in the positive category and some in, you know, negative numbers. The next thing you do is square those, and that makes them all positive numbers. So minus 1 squared is 1, and minus 2 squared is 4, and 5 squared is 25, and so on. So now we have all these figured. In fact, let me go back to, you see this, we did observed minus expected, and now we've got squared, right? And then the final thing we do is divide by expected. So the expected is 4, so we divide all these numbers by 4. So 1 divided by 4 is 0.25, is a quarter, and 4 divided by 4 is 1, and so on. So we wind up with all these, and we add them up, because if you go back here, we got it, you know, we've divided by expected. We have to go do the sum of. And you add all these up, and the sum we get is 16.5. And that's our x squared. That's our chi-squared. It's our statistic. Now, what we do is we, go back to this figure here, x squared, chi-squared, sub alpha, comma, n minus 1. So let's do x squared, and for sub alpha, we'll use 5/100ths. That's the 95% confidence level. And then n minus 1 is 11, because it's the number 12, samples, 12 categories minus 1. And we come up with a statistic, which I'll show you how I got in a minute, 19.68. And then we also do it for the 90% confidence level, and we get 17.2a. Now, in this case, we're not going to reject the null hypothesis, because in both cases, the statistic, chi-square, is less than, I'm sorry, the null hypothesis, x squared, this is over here, 16.5, is less than the significance levels at 0.5 and 0.10. So let's see what that looks like. We know what our statistic is. It's 16.5, right? So we go to this, and we have our degrees of freedom, 11, and we go down here, and we're going to go to the 0.05 confidence level up here on the x-axis. And that gives us 19.68. And if we go back, that's what I wrote down right here. Now, if we would go for the 90% confidence level, we got 17.28. And that's that. So in this case, the chi-square says that we shouldn't reject the null hypothesis. If there's nothing significant here, terribly significant, that our statistic is less than the significant levels at 95 and 90%. Now we could go to this at the 25% level, and we come up with 13.7, and that's less, so it becomes significant at a lower confidence level. But like I say, in statistics, you want to go for this golden standard of 95% confidence, which, if you heard my talk the last time, that's now you're getting to two standard deviations from the mean. Okay, so usually what happens when you do chi-square, you go to one of these tables, and it basically tells you the probability of a larger value of x squared or chi-square. So now what I did was I took the wrappers by element, and I organized them according to fire, earth, air, and water. So we have more than 10 over here, looks like about 12 in fire, and it looks like we've got about 8 in earth, but we've got, looks like about 22 in water, and 6 air rather, and then 6 in air. So yeah, when I made this graph, I found that I couldn't get this stretched out enough. Some of the graph making business on Excel or OpenOffice is a little tricky. Look, I got a jittering thing there. Anyway, so here's what it comes down to. We have the same graph that you just saw, and we have the element, and we have the observed, and the expected, and the observed minus expected, and the squared, and the divided by expected, right? So we're going to go through the whole thing again. If we have 48, our sample is 48, and we have 4 categories, then, whoa, what did I do? Okay, then the expected would be 12 each, right? The distribution would be 12 of our sample in each of these 4 categories. So we take the observed versus expected and minus expected. So we have observed 12 in fire, we expect 12, we get 0. We observe 8 in earth, expect 12, we get minus 4. We observe 22 in air, we expect 12, that's 10. We observe 6 in water, we expect 12, we've got -6. So then we square these, and we come up with these figures here. -4 squared, 16, 10 squared, 100, -6 squared, 36. Then we divide them by the expected. We divide all these numbers by 12, and we get 0, we get 1.33, and then we get 8.33, and then we get 3, and we add them all up, and our statistic, our x squared, our chi-squared, is 12.66. So if we go back to our table here, and we know that since there are 4 categories, and we have to do our n-1, degrees of freedom is 3, we look at this 3 column, and what we find is that at the 0.05 level, the 95% confidence level here, we have 7.81. And that is less than our statistic here. So it's greater than the significant level at 0.05, and it would also be true for 0.10, which is 6.5. So you can see here that if our the statistic that we came up with, which is 12.66, we go back to this column here with 3 degrees of freedom, it's off the chart. It's more than 99%, right? 99%, which would be 0.1. I'm having a hard time with this mouse here, staying straight. Okay, yeah. It's higher than 99% that we get that result. So this is, a fairly significant finding that, of these rappers, that the majority of them were born, a statistically significant number were born in air signs. And I worked it out that the actual value is, it's 0.0054. So this is very statistically significant. So that's how it's done. Now, there are problems with this. I mean, if I were a critic of this thing, I would say, first of all, 48 top rappers, who decided that these were top rappers? What's the criteria for that? Does it mean in terms of sales, how much, money their product, makes when it's sold? Is it the number of public appearances? Is it the number of fans that come to their shows? And who's the person that's picking these out? And then of course there's the problem of the distribution of the births around the year. That this is the assumption I've made here is that the number of births per sign is regular. With 48 people, that's 4 per sign. All through the year, and it's not. It's a little different. So I didn't figure that in. It's not a big factor, but it hasn't been figured in. But this is something to go by. This is something to consider. And if we could get a bigger database of rappers, we could try it again and see what happens. But the real problem is selecting your sample. And in just take music, for example, or acting or any kind of art form. You have people that are very, very popular, and they make a lot of money and they get a lot of attention. But that doesn't say that they're the best, because you get people at the top and then you ask them who they like, and probably 90% of the people that they're impressed with are not that well known. If you're a guitar player, I mean, there are plenty of guitar players that are highly respected by the best in the field, but are just, not that well known. I recently saw, I've been a guitar player all my life, and early on, I was very impressed with and influenced by a guitar player named Link Wray from the 50s and 60s. And I was always a big Link Wray fan, but he was never, known. Almost no one that I knew who knew who this guy was. But then a few years ago, a movie came out called It Might Get Loud that had Jimmy Page and Jack White and The Edge, you know, some other guitar players talking about who their heroes were. And Link Wray comes up and Jimmy Page is just raving about this guy. So here's Jimmy Page, top of the pecking order about, you know, just about on guitar playing. And he's raving about Link Wray. And, you know, and recently a film came out called, you know, Rumble, the Native Americans that rocked the world. Because Link Wray was, you know, part Shawnee, I think. You know, if you look at him, he looks like an Indian. But, you know, so this raises the question, who do we really count when it comes to, you know, top, in this case, rappers? There are probably some rappers out there that are a lot like Link Wray. They were like, they influenced everybody else, but they never made a lot of money and didn't get really popular. Should we include them in the sample? Because, you know, this raises the question of what are we actually measuring? Are we measuring the actual ability to do rap? Are we measuring influence? You know, if somebody is less well known but influences all the people that make a hit, how influential are they? So these are the problems that astrologers face when you're dealing with people and you're trying to measure something. And if you get all rappers, everybody that does rap, now you've got a problem because there's probably going to be a lot of people there that are terrible, that aren't influencing anybody and aren't really contributing anything. Popularity, from my experience, seems to be measured more by the configuration of the natal chart relative to the solstice axis or the Aries axis. And that's something out of Uranian astrology, you know, where 0 degrees of the cardinal sign seems to be the magic factor in determining how broadly somebody's influence is likely to be expressed and in what way. But I don't know that anybody's tested that. Anyhow, that's my presentation of the chi-square test. That's what it is. And you can see why it's used frequently in astrology, because it works well with these categories of signs. You know, measuring other things is a little different, but if you're looking at numbers of signs, and I think with internet data now, this kind of work can become more and more interesting and maybe more and more significant, you know, in understanding what's going on when you're dealing with like really large amounts of data. This kind of study, you know, could be very interesting.
So that was, I think, a really good example of somebody starting out looking at signs and ending up going to the elements. There's a lot of evidence for the elements. And let me see what's going on in the chat. We've got some more comments here in the chat. And all these problems, this is from Teresa, astrological research seems kind of difficult, if not hopeless. Great presentation, though. Great coverage of the problems we face. Well, again, I've got a literature review in an article coming out of dozens of studies that show statistical results for the elements. It's getting easier. You know, QSD's got over a dozen peer-reviewed articles published with you know, peer-reviewed positive results. And I think that it doesn't take a lot of talent to muddy the waters and walk away going, oh gosh, we don't know, we'll never know. You know, what takes some talent is to get to the point and, you know, really size up the problem enough to come up with a solution. And the really talented researchers do that, and that's why the evidence is piling up. Yeah, there are a lot of questions, and the questions he was raising, you know, Gokulan and Ertel wrestled with the whole issue of imminence and came up with an imminence ranking system that, you know, cut through a lot of the confusion, even though some people still argue with it. But don't let that stuff deter you. There's plenty of people publishing papers with positive results, more and more so every day. So it definitely can be done. And there's a lot of good examples out there. Mitch, are you ready to go with the software?
Yeah, I'm ready to go. Tonight I was going to take a look at Kepler, the software features that are available in Kepler. Let me get back to Zoom now so that I can share my screen, and it'll show up. There's Kepler. Two weeks ago, we took a look at Pegasus. This week, we'll take a look at Kepler. Kepler comes with data. It does not come with the set of data, the full set of data that Sirius comes with, or that you purchase with Pegasus. It comes with about 20-some thousand observations, I believe. For another $50, you can get the full set of data that Sirius has. Kepler itself costs $300, I believe. So by the time you get the data, it's another $50. That's $350. That's still a lot less money than Sirius. You're not going to get all of the features in Kepler that you get in Sirius, but you get about 90% of the features, I'd say, of Sirius in Kepler. I want to go ahead and look at some of the research features real quick compared to what we saw last week. We took a look last week at the astro signatures. You'll recall that those are where we can actually look at the actual scores, how people score on different kinds of criteria: logic, technical detail, mental concentration, psychology, anthropology, humanities, literature, poetry, fantasy, fiction. And you can go and you can select accuracy. You can select only charts that have, for example, A or better accuracy. You can change the category or keyword so that you can select famous people only, or you can select mundane data, or you can go ahead and select a more specific category. You don't have as many categories, I don't believe, as you do in Sirius. Maybe you do. But there are a lot of categories here as well that that are already in the data itself: writer, author, critic, and then underneath that you can go to nonfiction or writer from the Gauquelin data collection, fiction, poetry, plays, novelist, humor. Yeah, so they're a little bit different than they are in Sirius. It's just reflecting the smaller amount of data that's available in Kepler. But if we wanted to look at all of the fiction writers, for example, we could with AA data, and then we could rank them. We could rank them on their sexual excitability. We could rank them on their childlike exuberance or whatever. Let me get rid of that in the nakshatras. You have matchmaking. I haven't used matchmaking. You would have two sets of charts, and it would literally rank the matches between the two charts of data. So if you did the writers of fiction, poetry, etc., and you do the astrologers, you can rank them on romantic and sexual attraction, or similarity of interests and temperament. 28 degrees we see here has got a spike. There are other spikes throughout the data. The question is whether or not they're statistically significant or not. We would have to do some more analysis with some control groups in order to determine whether or not they're statistically significant.
Aria has a question. She's asking, can you do the relationship compatibility in Sirius too?
Oh, yes. Anything that you can do in Kepler, you can do in Sirius. The way Pegasus, Kepler, and Sirius work is Pegasus is considered the introductory software by Cosmic Pattern software. Kepler is considered the professional, and Sirius is considered the advanced. And so all of the features of Pegasus are in Kepler, and then there's a bunch of features in Kepler that are not in Pegasus. And the same thing is true with Sirius. There are features in Sirius has all of the features of Kepler and then adds on a bunch of features. I can show you, you see Sirius at the moment when I just clicked on it, or is it still showing you Kepler?
I think that is still Kepler. Yeah, Kepler 8.0.
Okay, I'll unshare the screen quick and then share it with, and then I'll bring up Sirius. There's Sirius. Can you see Sirius now?
Yeah, that's Sirius
3.0.
Yeah.
The latest version. These are the research capacities in Sirius, and you'll see that there are more of them in Sirius than there were in Kepler. But everything that was in Kepler, the exploratory assumptionless research, the midpoints and harmonic patterns, the quantitative transit and synodic cycles was available in Kepler. It was called something else, but it's there. What's not available in Kepler is, for example, is make data for stat software or control group. That's specific to Sirius. So I'm going to stop share screen on Sirius and go to Kepler. So I brought Kepler up for just that emergency. I mean Sirius up for just that emergency. Okay. I probably did that wrong because you probably can only see the Kepler with the thing in front of it. Now you can see Kepler, right?
Yes, that's Kepler 8.0.
Right. And you can't see the window. I'm probably going to have to kill off the window. I'm sorry to have to do this, folks, to make you see this. Probably going to have to kill off the research window. Okay, you can still see it stopped, and it has stopped as the shared window is closed. Okay, that's fine. Now we'll go back and share one more time. Kepler. All right. Now we bring up again the list. So you can see that there's a smaller list of options available in Kepler. That's why I'm doing the walkthrough on Kepler this week, and then 2 weeks from today, I'll do the walkthrough on Sirius. There is this midpoints and harmonic patterns. I believe that's available in Pegasus. It's hard to keep them straight. That's why I brought up all three to look at. I believe I walked through this last week. For example, you can look at the sun, midpoint to the moon and Mercury, and it will pull up all of the charts in the writers of fiction and poetry that have that particular midpoint. If I click on OK, and that was very fast, it ran, and you can see that, for example, Leo Tolstoy and Gay Talese, very famous writers, Anatole France, Emile Bronte, Emily Bronte, they all have that midpoint. The quantitative synodic cycle analysis, to be honest with you, I have looked for, in the help system, a description of that. There's no description in the Kepler help system for what this does. And I'm not quite certain what it does. So I don't use it. It's the data seems to be commodities, gold, the British pound, copper. If I go and try to display the graph, it's going to tell me that I'm outside of the data, so I'll go to 1991, go within the data, and it will display a graph beginning on the 2nd, and that's the British pound, but I'm not quite certain. This is a transit to transit, Sun to Jupiter, 0 to 360 degrees and the scores. And I'm not quite certain what this is showing, what utility this has. If somebody else wants to explain it at some point, I'd be glad to turn over the mic and let someone else explain it, because it's not explained in the Kepler documentation.
Does anybody in here know what this is? If Linda were here, she might know, but
Linda might know if she was here. I believe that it's there for, I mean, it's got mundane data and it's got personal data built into it. It's old data. So the specific astro factors are, as it says down here, selecting a very specific research category speeds up the calculations dramatically. But this one here, it was available in Pegasus. It doesn't do a whole great deal. You can select the planet and the tropical, and it'll go ahead and calculate it, accuracy A. And what you can see is the total in each sign, the total number of observations. And we can see that, for example, there's 0 in Capricorn out of the 47 charts. So 0 of the authors in Capricorn. There's 1 in Scorpio. But then on the other hand, there's 6 in Aries, for example. And if you wanted to know what sign they were under, that data is listed up there too. So that's where the sun was located at. You can do number of charts with the selected attributes. 156, 44 charts were selected out of 156 charts examined. So there were 44 charts that had the sun in a fire element. So you can do some basic research with using the specific astrofactors. Most of the time you'll be working with actual astro signatures. The electional astro signature, that one was available in, I showed that in last week in Pegasus, 2 weeks ago in Pegasus as well. That's one where you can select for a given person, your given chart that's up, like mine right now. I can select between October 16th and November 16th, for example, and it will rank out my likelihood of business success, my drive, my ambition. You can check more than one if you want to. My imagination and confusion, and you begin the analysis, and it will print off a nice little graph that's sort of like a biorhythm, shows how, well, you can see it's rather flat here for imagination and confusion. It peaked on the 1st and then went down to 0 for the rest of the month, so that's not a happy outcome for Mitch. My drive and ambition.
What's the green line? Is that the drive and ambition? That's
my drive and ambition. So my drive and ambition is going to be high around the 27th of October. It's going to be at its peak at around the 27th of October. Don't want to print that. I want to go back to the previous screen. Sometimes you have to hunt around on the screens in order to be able to go back and get out of what you were in. So Kepler has more research features than Pegasus. If you're going to be doing research, I would recommend Kepler over top of Pegasus. But as we'll see in 2 weeks from now, or I can do it now, we have a few minutes left. Let's take a run through on Sirius real quick, since we're here and Sirius is up, because then that way we can go next week. We can go into something else like Jigsaw or something like that in 2 weeks. I'm going to first have to go up back to Sirius, click off on the menu that I left open, which is going to bot me out. I'm sorry, folks. And now I can go back to Sirius.
Mitch, just a quick question from Alan.
Sure, sure.
Mean and true nodes in Kepler?
Yeah, you can do mean and true node. You can choose. That's under settings. If you go to settings and then other settings, I think it's under other settings.
Okay, but
Astro settings right there. You got the choice of a true node or a mean node.
it seems to me it said one other evening that that was not available in Sirius.
No, it's available in Sirius.
Is it? Okay, I'm thinking of
This
something else.
is Sirius right here, and this is where you choose the moon's node.
Oh, sorry, but I'm asking about Kepler. I'm sorry, I thought you were still there.
Kepler will let you do the mean or true node too. I'm pretty sure.
Yeah. Okay.
Let me check real quick. I'll check real quick.
Yeah, even SolarFire will give you a choice in the settings.
Well, who is it? Alfie Lavoie doesn't allow the mean node. Would this come up in conversation one other evening?
Yeah, Kepler allows it.
Yeah. Okay. Maybe I'm confused. Okay, I don't want to take any more time.
Okay, is it in the Air software that you can't make that adjustment?
I'm pretty sure you can. I could be wrong. I'll be demoing the Air software.
Okay, we'll get to it in due course. That's okay.
But yeah, you can work with true nodes in Sirius, for example. So here we have the research options that are available in Sirius, and it's an expanded set of research options. The first set under Astro Signature is the same as Kepler. The one big difference that you have is you have the ability to make data for stat software or control groups. That was necessary for me, for example, for the prisoner data that I'm working on, because I needed to get the data out of Sirius and I needed to load it into statistical software. And I didn't want to be calculating out the position of the planets or the speeds of the planets. So with Sirius, you have this ability to make data for stat software or control groups, and I can go here under individual charts, one category of charts, and I can, for example, pull out the writers if I wanted to, and then I can choose what data I want to pull out. Planet positions and speeds would be what I would pull out for the most part. That's what I pulled out for the prisoner data. And then you decide what to name the file. You decide an ID field for all of the data. That'll create a variable in there called group 1, for example. You can decide if you want to make control group files. I've not used that feature, and then if you click Save Data to File, it will actually save the data out into a CSV file called mydata.csv. And now it's pulling all the writers and authors and critics from Sirius, which is a much bigger set, as you can see, than we had in Kepler, because we're already out to 50-some hundred observations.
We have a question from Maureen. She's just asking, how much does the Sirius versus Kepler software cost?
And there the data's out. The data, the difference in price is between $300. If you add on the expanded data set, it would be $350. And then if you added on the auto rectification module, that's another, I think, $100 and some odd. So you come pretty close to the price of Sirius to get Kepler fully expanded out. Sirius is $550, I believe. It's pricey compared to something like SolarFire, which is in the mid 300 range. Sirius is in the mid 500s, 550, I believe. If we go to mydata.csv, which will be hiding in my, I don't want to go leave the screen share to show you the data, but it's in a comma separated values file. You could load that into a spreadsheet if you wanted to, because Excel will load up a comma separated values file without any problem. I loaded into a statistical package called SAS, SAS. You can load it into SPSS. You can load it into the public domain statistics software called R, etc. So if you want to do serious statistical work with the data, you can export your data that way. You cannot export your data for use in another statistics software package quite so in quite such a user-friendly fashion way. It's just as it was with Pegasus, and it's the same in Kepler. If I go under export birth data, if all I wanted to do is export out the names of people, the dates of birth, the times of birth, the place of birth, if I want to put it out as I showed the data before with all those lines in between, and Linda saying, you know, that there are ways of being able to go into the spreadsheet and get rid of all those extra lines. If you want to wrestle with that data, then you can actually go with a specific research data that you want to go with. You can select a specific research category. You can select your data. You can pull out your clients. You can pull out your friends. I could pull out my mass shootings data. I could pull out my federal inmate survey data. Those are all separate categories that I have in my serious data. But if I don't want to pull it out in that god-awful text format, if I want to export my birth data in, say, NOVA format, I have to take all of my data, which would mean I'd have to take all of my mass shooting data, all of my prisoner data, all of my client data, and that's not what I want to be able to do. You have the same limitation in all three of the products in terms of being able to export out birth data. View birth data sorted by date, that's available in all three of them. So the only real research data that I can see that you get the make data for stat software or control group is the only real feature that you get. You get a little difference here from Sirius. Before, the Sirius referred to natal synodic cycles, and I mentioned, you know, somebody could tell me what that's doing, I'd be happy. Here you've got two choices for that line graph: the scores by transit or transit to natal angular distance, and a line graph scores by natal angular distance. So here he's using need for solitude, need to be part of an organization, stubborn, inflexible, predictable. I'm not quite certain. Let's go ahead and run it. Test scores. No, that's not what I want to be able to pull. That's for selecting observations, test or measurement scores. Changes have not been saved. Oh, help. This one has a help. By selecting planet equals sun coordinate, right ascension. That is, features to see if scores on a test or a performance score of some kind correlates with an astrological factor. Because the sun is associated with being simple, serious, and introverted in the seventh harmonic, according to David Cochran, I'll have to study this better. I'll have a better answer for what this does 2 weeks from now. I wasn't prepared to talk about this feature tonight.
Well, there's a lot in there. You know, it's hard to I think take it all in, you know, in one shot, because there's just there's a lot.
Mm-hmm. Trying to unshare my screen, and I went to the wrong place.
Aria has a question.
Mm-hmm.
She's asking, I wanted to know the process he uses to test around. What do you do? Do you create a question you try to answer, or do you click around and go where the path leads?
That's a good question, and something that we can talk about in 2 weeks, coming up with a research question and how we go about testing a research question.
That's a great idea. You know, thank you for raising that question, Ari. That's a great idea.
Yeah, that's something to talk about in 2 weeks. David has a bunch of astrosignatures that he thought would be useful for ranking charts on scientific aptitude, painting aptitude, musical aptitude. They've been based on the research of the Gauquelin data, for example. So he came up with using the Gauquelin data, he came up with his own astrosignature. You can create your own astrosignatures. Let's go take a look.
That would be a great exercise to do in class, you know, even if we took one of the students and used one of their charts to test some of those astrosignatures on and get their feedback on it, you know. Mm-hmm. There's a lot of different ways we could do that.
I agree. For musical aptitude, what David is using, he's using his harmonic astrology. So he's using Sun Saturn in the 7th. He's using a conjunction in the 7th, apparently, it looks like to me. Sun Saturn in the 14th only, Sun Saturn in the 28th, Mercury Saturn. So he's using Sun, Mercury, Mars, Saturn in harmonic aspects. And that's what he used for determining musical aptitude, using the Gauquelin data. So it would be interesting, for example, what I would do would be, instead of looking at writers, for example, I would go down under, again, selecting a more specific category. I would go not under my categories, but under famous and research, and go to musicians.
Can we actually plan to do that, like in the next mm-hmm. class? I think maybe if we've got a couple of weeks to put some concise and cogent questions together that we could test in a reasonable period of time, just to get a sense of, you know, sure. Maybe how well some of the calculations in their work, or maybe test it against a student's chart in the class, and they can try to give us some honest feedback on how well they feel it fits them. You know, I think that would be really interesting, and a little less abstract and more, you know, applied to an actual question. I think that would be a lot of fun. We've mm-hmm. got some other comments. Aria is asking about, she's saying, is that for musical aptitude? You said that's interesting.
Yeah, I'm running the musical aptitude against musicians right now. So it's going to rank all the musicians on David's musical aptitude score. That's what's running right at the moment. It's already blitzed through 880 charts, 900 charts.
Are you sure he didn't derive the score from that group?
No. The musician data is broader than the Gauquelin data.
It is, okay.
I'm not certain how many musicians there are, probably 5,000 or 6,000, 7,000 of them, something like that. But certainly next week we can
next class, not next week.
Class. I know, I keep saying next week and last week.
We're still doing that, yeah.
I know. 2 weeks ago, in the next fortnight, we'll do the British term, a fortnight away.
Yeah, I think that will really be a good exercise, because then we can really apply, you know, the features in there to something that you know, that people either want to know or that they can relate to as individuals, and that's always helpful.
I'm going to stop it running and let it just tell me how as far as it got. We can see that some of the Gauquelin musicians are in there. So we want to go for a narrower group. They're not all Gauquelin musicians by far, but and it's going to rank them from highest to lowest. I didn't give it a chance to do the rankings, so it's all zeros. Yeah, right, cut it off. But that's the kind of thing that we can look at next time.
Yeah, we could even use some of those rankings on students in the class, you know?
The one-person rankings, yes.
The one-person ranking, yeah. Yeah, all right, well that's definitely something to think about over the 2 weeks. And as I said, maybe we can come up with some concise questions that we could.
Right. Right. For the research, for the students, we can do this one here, down here, the lectional astrosignature forecast of one chart.
Okay.
Like in my case, it's my chart, but we could do Aria's chart. We can do whosever chart we want to do. Okay.
Yeah, I think that would be fun, and then we can, you know, really get in there and watch it work. That was very interesting, and I you know, I was thinking after Therese's left, but you know, she brought up that article. I'm going to kind of pursue that and see if, you know, maybe we need to add a little bit of historical context to the Nakshatra Project that she just interjected.